All right, so identities. Basically, are equations that I already give you the answer at the start of the problem. So the big rules is you write down the problem the way it appears in the book. Okay? Then you are only going to change the left side of the equation, leaving the right side alone, but you'll be working down as you go, writing the right side down each time. And I want you to work vertically, Spencer Reverts, not horizontally. So your equal signs are all lined up so we can see exactly what's going on. So trying to fit things in small spaces doesn't work so well in identities. I want them to be done vertically. And you'll see, I'll give you 3 examples here before I give you the assignment, and you'll see what I mean by working vertically. Do you have pencil lead? No. Okay. So, do you have multiple pencils?
No. I have lead. I legit have the one pencil. I'll use a colored pencil. I have lead.
She's
Lead in it. You have a pencil,
pencil but no lead. Thank you, Taylor. Okay. So now that you have the big rules all written down, we're going to look at some examples. Example number 1. Let's say the cosine of x times tangent of x equals the sine of x. Basically, you're going to prove how the cosine of x times the tangent of x is going to equal the sine of x. Okay. Now, we can only change the left side of the equation, the cosine of x, tangent of x. We can't do anything to the right side. Okay? So, which thing on the left side of the equation are we going to change? Tangent of x. We're going to rewrite tangent of x as sine of x over cosine of x. And Maggie says cancel the cosines, the end. She's not quite right. We're going to write one more line that the sine of x equals the sine of x. And then we are done. The end. I did.
Why do you have to write it all out?
To prove it.
Struggle for me. Yeah, right. So I just go. I answer that whole thing in my head.
Yep, I know. And yeah. And Kevin Sean even missed points in this chapter because he knew it and then he skipped steps.
I know. He got a 36.
He got a 36 on his yeah.
He got a 36 on the ACT. He's my neighbor.
Yeah. Okay, let's look at this one. 1 minus cotangent squared times secant squared equals cotangent squared. Ooh. So, we can only change the left-hand side. What on the left-hand side would we change? Secant, is that it? What should we change cotangent into? Cosine squared of x over sine squared of x. What do we change secant into? 1 over cosine squared of x equals cotangent squared of x.
You can't change the right side at all?
Not at all. You don't even rewrite it as cosine squared over sine squared. Nope, you leave it the way it is the whole way down.
Can you cancel your cosines?
All right, so cancel my cosines. So I get 1 minus 1 over sine squared equals cotangent squared of x. Now, looking at your note card, there's something to do with cotangent squared. So, I mean, I can go way complicated on this, or I can go fairly easy on this. Maggie's saying we go put it into cosecant. So if we rewrite 1 over sine squared as cosecant squared of x, I know my Pythagorean identity, which says 1 plus cotangent squared of x equals cosecant squared of x. Oh, I bet this is negative cosecant squared of x. Negative cotangent squared of x. Yep, that should be in. Or
so make it positive. Make it 1 plus
yeah. But we're fine with this. Okay? It should equal negative cotangent squared. That's the way it should have read in the book. Yeah.
The whole time?
The whole time it should have been that.
Big rule.
My first big rule is write it down the way it appears in the book. I wrote it down wrong the way it appeared in the book. Okay. So what's 1 minus cosecant squared equal to? Negative cotangent squared of x. And they match. What you want to do is you want to keep working down until they match. Example number 3. Sine squared cosine plus cosine cubed over cosine equals 1. How can that complicated mess on the left side equal 1? Well, it's super simple easy how it equals 1. What would be your very first step of this? Take a cosine out of the top, Taylor says. Let's do that, because there is a greatest common factor of cosine of x in the numerator to get sine squared of x plus cosine squared of x over cosine of x equals 1. Now what happens? We can cancel cosines. And what I'm left with is sine squared plus cosine squared equals 1. That's one of my identities. So 1 equals 1. You cannot simply stop at sine squared plus cosine squared equals 1 and say, hey, we're done. Nope. I need to change sine squared plus cosine squared into 1. So 1 equals 1. So in your very last step, your last lines should match. Okay? Okay. 37 through 42, all page 172. In 20 minutes, or so, we will go through these. And then after lunch, we'll go through another couple problems. So we will go through the answers to these in 20 minutes. So you have the next 20 minutes to work on these 6 problems.